Question 3, we've got Robert Millikan's experiment, 1909, determining the size of the charge on an electron. Put a tiny charge on a tiny drop of oil, or tiny charge. Put a charge on a tiny drop of oil and measured how strong an applied electric field had to be in order to stop the oil from falling. The diagram below shows a simplified version of the apparatus he used. So there's the power supply, the oil drops in the middle, gravity is pushing down, the electric field is pushing up on the droplet. So, he used X-rays to produce a negative charge. That's irrelevant. Explain why the battery is connected as shown in the diagram. Well, that creates, this is the positive side of the battery, so it creates positive field on the top here, and therefore negative on the bottom. Positive charges, not positive. So the electric field is running this direction, but if you're a positive charge, no, it's not running that direction. If you're a positive charge, remember we always describe it in terms of the direction that a test charge, the positive test charge you chucked in there, they would experience a force downwards. But remember, the oil drop has a negative charge because we've produced a negative charge on the oil drops. The X-ray part's the irrelevant part. And therefore we need to have an attractive force upwards due to the electric field, because we need to balance out the force due to gravity downwards. And that's the whole point of it. That's why it's oriented that way, because a negative charge needs to be attracted to the top by a positive plate. B, in terms of forces, state the conditions necessary for the oil drop to be held stationary between the horizontal plates. In terms of forces, the force due to gravity has to be equal but opposite to the force due to the electric field, which, if you're drawing a free body force diagram, this would be the force due to the electric field, and they're both equal. Fg is equal to Fe, but they're in opposite directions. So that's the main thing. Yeah, if you wanted to get in more detail, you would say the electric field times the charge, because that's the force, F equals EQ, and force due to gravity is mg. Interesting how both of these are very similar. Q is your charge, which is your electric equivalent of mass, and E is the electric field strength, G is the gravitational field strength. So those are very similar formula.